All right, let's continue with our discussion on redox reactions. Here's just a few examples of substances being reduced. Notice that when something is being reduced, the electrons are going to be on the left-hand side of the equation. They're gaining those electrons. Remember, reduction is gaining. So when you gain electrons, the electrons appear on the reactant side of the equation. Okay, when things are being oxidized, oxidation is losing. So here you can see that the electrons are on the product side. And in general, metals tend to lose electrons, so the metals are the ones that are oxidized. And if you think about it, for an atom to lose an electron, it comes back to ionization energy. And remember that as you go across the periodic table from left to right, the ionization energy goes up. So what elements have the lowest ionization energies are the elements over here. So what elements are the ones that are most easily oxidized? Elements that are over here. The farther you are to the left, the easier an element is oxidized. Okay, all right, so here's an example of a full, so these up here, these are what are called half reactions. We'll talk about those in just a second, but notice this is just the reduction process, and this is just the oxidation process. Okay, here you can see this is a full equation where sodium is going from a 0 charge to a +1, and chlorine's going from a 0 to a -1. So the sodium is being oxidized, the chlorine is being reduced. Okay, now again, you can split those up into what we call half reactions. This is the oxidation half reaction that shows sodium going from Na to Na+, and then here is the reduction half reaction where Cl is going from Cl2 to Cl-. Okay, you will be expected to balance equations using the method of what are called half reactions. So here are 6 different steps that you're going to follow to do this. And to me, instead of reading all of them for you, I know you know how to read. So I will look over in example 1. I will just do one of these examples for you so you can kind of see as I go through the steps. So step number 1 is to convert it into 2 separate processes, the oxidation and the reduction process. So here we're trying to figure out what's being oxidized and what's being reduced. Okay, so let's start. I want to start with an easier one than letter A. Let's start with letter B here. So the first thing we're going to do is we're going to try to figure out what's being oxidized and what's being reduced here. Usually it's not oxygen. It can be, but usually it's not oxygen and not hydrogen. Usually if there's other things in there, like I'm kind of looking at the manganese and the carbon, because those are the only things in there other than the the hydrogens and the oxygens. So manganese over here has an oxidation number of +7. Here it's +2. So there we can see that the oxidation number is being reduced. So one of our half reactions is going to be MnO4- becoming Mn2+. And I don't even care if it's oxidation or reduction. It's going to show itself as to what it is, even though we know it's reduction. It doesn't really matter at this point. And then C2O4 let's see, so this is -8, and we need to get back to -2, so this needs to be +6. So the carbon's going to be +3 there, and here we've got -4, so the carbon is +4. So you're going from +3 to +4. So C2O4 becoming CO2. Okay, so we have split that up. Now, what do we do with the H+ and the H2Os? Nothing. Okay, we're just focusing on what's being oxidized and what's being reduced. And again, we don't even care which one's which at this point. So that's step number 1. Step number 2 says balance the elements other than hydrogen and oxygen. So anything that's not a hydrogen or an oxygen, we're going to balance. So the manganese, balanced. There's 1 manganese on both sides. But here we have 2 carbons. This side we only have 1. So we're going to throw a 2 on there. Okay, number 3, balance the oxygen atoms by adding water. Okay, let's focus on that part. So we have 4 oxygens in MnO4-, so we have to put 4 waters over here. And in this case, our oxygens are already balanced, 4 oxygens on both sides, so we're good. Okay, and then it says balance the hydrogen atoms by adding H+. So let's see, in the first one I have 4 H2Os. That's 8 hydrogen atoms. So I need to put 8 H pluses over here on this side. In the bottom one, there are no hydrogens, so we're still good there. And then it says balance the charges by adding electrons as needed. So here's how we have to look at both sides of the equation. What's the total charge on both sides? For example, here I see 8 positives and 1 negative. To me, that's a +7 on this side. And on this side, the total charge is +2. So +7 on one side, +2 on the other side. I need those numbers to be the same. So what I'm going to do is I'm going to add 5 electrons to this side. 5 -1 charges brings that +7 down to +2. Okay, and then on the bottom one, I see a -2 on the left-hand side and nothing on the right-hand side. So to make them same, I'm going to put 2 electrons on that side. So now notice my 2 equations, and it has to be this way, where one equation has the electrons on the reactant side. That's the reduction process, which again, we already knew. And one of them has the electrons on the product side, which is the oxidation process. Okay, don't worry about step number 4 yet. We'll look at that in a later example. Number 5 says multiply each half reaction by the appropriate number so that the number of electrons gained equals the number of electrons lost. So here we're gaining 5, but here we're only losing 2. We need them to gain and lose the same amount. So that means I'm going to take this top equation and I'm going to double, not just the electrons, I'm going to double everything. Okay, that becomes a 2, that becomes a 2, and that 4 on the H2O becomes an 8. And then on the bottom one that's very similar, I've got to multiply that by 5. 2 times 5 is 10, and then my 2 electrons become 10 electrons. Okay, and then add the 2 half reactions, step number 6, and simplify by canceling species that appear on both sides of the combined equation. The total number of atoms and the total charge need to be the same on both sides. We'll see what that means here. So certainly the 10 electrons, the 10 electrons. Many times some of these H pluses will cancel, and many times some of the waters will cancel. Because this one down here, we didn't have to add any waters to it, and then no H pluses either. None of that's going to cancel. So overall, I'm going to erase this in a second, but overall our equation is 16 H pluses plus 2 MnO4 minuses plus 5 C2O4 2 minuses makes 2 Mn2 pluses plus 8 H2Os plus 5 C2O4 2 minuses. See, and you thought balancing equations. No, I said that wrong. Sorry, my bad. Hold on. 8 H2Os plus 10 CO2s. There we go. Okay, and yes, that now we are done. Couple things to make sure though. Make sure that all of the elements are balanced. You have the correct number. If you've done this correctly, you will. Okay, and also check your charges. 16 positives minus 2 is 14. Minus 10 on this side, the total charge is positive 4. Over on the right hand side, much easier, 2 times plus 2, positive 4. If the equation is balanced and the charges are the same on both sides, the overall charge on the reactant side and the product side are the same, then you know you've done it correctly, and that is the correct balanced equation for that reaction there. Okay. So sometimes when you balance an equation, for example, this one down here, example 2, and then I'm going to stop and I'm going to come back and do those upper ones as well. Okay, sometimes you're like, oh, I need to balance this equation. 1 magnesium, 1 N, 1 N, 3 O's, 3, I got to put a 3 there. Okay, that's balanced. And then H pluses, I see 10 H pluses. The answer is 10. Sometimes that works. Okay, but a lot of times it doesn't work. Okay, by balancing it the normal way, that sometimes will work, sometimes it doesn't. The reason I know this doesn't work, it might for this part right here, That might be the right answer, but notice the charges. Notice that the charges, you've got a total charge of positive 9 over here and a total charge of positive 3 over here. That equation isn't balanced. And it might be something really, really simple and dumb, but it is not a balanced equation. You might get it right by putting that 10 there and going, oh, I don't want to worry about it. I'm just going to guess and put 10. Okay, but clearly there's something that's missing here. So let me go through this one a little bit quicker. So we've got mg becoming, or I'll do it down below here. So one of my half reactions is mg becoming mg2 plus. The other one's going to be NO3 minus becoming NH4 plus. We balance things that aren't oxygen first. They're already balanced. Then we balance the oxygens with waters. So I need 3 H2Os over here. And now we've got 6. We've got 10 hydrogens. So I'm going to put 10 H pluses over here. And now we need to balance our electrons. So to make this one the same, we need to put 2 electrons on this side. Here I see a plus 9 and a plus 1. So I need to bring this one down by 8. So I'm going to put 8 electrons on this side. And now I need to make the electrons the same. So I'm going to multiply everything up here by 4, 4, 4, and 8. And then again, the electrons cancel. So overall, we're going to have 4 mg's plus 10 H pluses plus NO3 minus makes 4 mg2 pluses plus NH4 plus 3 H2Os. Now, again, we got lucky. Okay, the correct answer, as you can see, the correct answer is, oops, right here, that is 10 for that hydrogen. Okay, but what if they had said, how many mg2 pluses are there? And you're like, well, if I balance it normally, you only need 1 mg2 plus. Okay, which obviously is not correct. Notice that now that we've done it correctly, the total charge here is plus 9, and over here it's also plus 9. The charges are the same on both sides. Okay, so go ahead and go back and try to do, well, I'm going to go ahead and stop this video now, and then I'm going to do these next 2 examples, A and C, in a separate video.